We're continuing on with graphing inequalities in two variables, and now we're going to apply this to a word problem, but it's also going to be a nice review of what you learned, hopefully yesterday, about just graphing inequalities in general. So in this situation, you're making cookies and brownies. The cookies are 3 ounces each, the brownies are 5 ounces each, and you're going to pack them into boxes, and you can only put 60 ounces maximum in that box. So you could do a different combination of cookies and brownies as long as they don't weigh more than 60 ounces in total. So there's a lot of different ways you could pack that box. But here's an equation that represents that scenario. We're doing 3 ounces for every cookie plus 5 ounces times the number of brownies, and that has to be less than or equal to 60 ounces. So the maximum capacity was 60 ounces, and the weight of the cookies and the brownies combined better be less than that 60 ounces. So I've just built an inequality that represents that scenario. These next two problems you could figure out either by equation or just by your own arithmetic, but it says, hey, could a box contain 12 cookies and 15 brownies? Or could a box contain 5 cookies and 7 brownies? No matter which one of those you're answering, you need to go ahead and weigh them. So I've went ahead and done the arithmetic on these. 12 cookies, 3 ounces each, 15 brownies, 5 ounces each. You add those two together, you get 111 ounces. That's way too heavy. You can't do that. 5 cookies and 7 brownies end up weighing 40 ounces in total. You do the math and you'll get it. And that's less than 60 ounces, so we can do it. Well, another way you can find out if these are a solution or not is to plug into this equation, or this inequality, and see if it makes it work. So let's do this one. If I plug in 5 cookies, 3 times 5, and 7 brownies, 5 times 7, that has to be less than or equal to 60 to make that a solution to that inequality. Well, this is 15 plus 35, which ends up being 50. I should have put this as 50 before. Oops. 50 is less than or equal to 60, making this a true statement, which makes this a solution to that inequality. But you could have answered both of these by just doing the arithmetic and not even worrying about plugging into the equation. For these two questions, write a combination that will fit in the box, write a combination that will not fit in the box. Well, you could pick any combination that you want that you know isn't going to work, and any combination that will work. So here I have put combinations down that I know will work and will not work, but here's how I could find out for sure mathematically. Take a 4, plug it in for x, take a 6, plug it in for y, and when I plug those in the end I should get some number that's less than or equal to 60, making that true or a solution to the inequality. If I plug these in for x and the 10 in for y, I'm going to get something that is false, and that tells me that's not a solution to the inequality. So for example, this combination that I said did not work, I went ahead and plugged it into the equation, or the inequality, and I end up getting 65 is less than or equal to 60. That's a false statement, which tells me this is not a solution to that inequality, and in the real scenario, it means we can't ship that combination of brownies and cookies. We're going to now move on to taking this inequality that we created out of these words, and we're going to go ahead and graph it down here on this coordinate grid. Now there's two ways you could get that done. You could go ahead and solve for y, or you could go with the intercepts. I'm going to graph it with the intercepts. So to graph with intercepts, you set up a little miniature t-chart, as you know from doing this before, and you take a 0 and you plug it in for x, and you see what y is going to be. So the best way to do that is say, if I plugged in a 0, 3 times x would equal 0, so that can go away. Now you just have to solve 5y equals 60. You might be able to do that by mental math. That's a 12. If you can't do that by mental math, break out the calculator. For the other one, if y is 0, what is my x going to be? I'm wondering what that's going to be. Well, if y is 0, that means you ignore that term. The 5y becomes nothing. So 3x equals 20. X must be 20. Sorry, let me restate that. 3x equals 60. And if I solve 3x equals 60, the x would have to be 20. So now I have the intercepts, and I can plot them on the graph. 0, 12, 20, 0. I have my two intercepts. I go back up to the original problem. It's a less than or equals to, which means I don't use a dashed line. I use a solid line. And I'm going to go ahead and get that done. And now I need to do some shading. That's the third part of the inequality. So I can use a test point and go ahead and shade. So I chose to test the point 10, 2. There it is right there. And when I plug in the x equals 10, y equals 2 into the equation, I end up with a true statement, which tells me that my test point is in the true region or the shaded region. So now I would go ahead and shade. And now I have my shaded region or my solution region. So this next question says, plot the point 5, 7. I've already done that. It's right there. And what does this represent? Well, the 5, 7 represents 5 cookies because x represents the number of cookies, and 7 brownies. These are what we're going to try to put into the box. And the fact that it's in the shaded region tells me it's in the solution region or the true region, which tells me that this is a combination I can put into the box and be under the weight limit. So 5, 7 being in the solution region tells me that this combination of 5 cookies and 7 brownies will fit in the box. This last part, 12, 15, indicates that 12 cookies and 15 brownies, there it is. It's outside the solution region, which tells me it's not a solution to our inequality, which in context of the situation says, nope, you can't do it. It's too heavy for that box. I'm going to go back for a minute and take a look at when we graphed this equation. We graphed it by intercepts. But if you didn't want to graph by intercepts and you'd rather solve for y, you can also do that. So here was the original inequality. I moved the 3x over to the other side. To get y by itself, I divided each side by 5, and I ended up with a y equals equation, a y equals inequality, because we have an inequality sign here. And there's my y-intercept. My slope is negative. That means my line is heading downhill. A fall of 3 and a positive 5. Negative 3, 1, 2, 3, a positive 5, 1, 2, 3, 4, 5, and I land on that spot. Down 3, over 5, I land on that spot. So you can do solve for y, or you can go by intercepts. You should be able to do both of those. Okay, this has been a review of doing inequalities with word problems, which is also a review of graphing with inequalities.